If you live in the urban centers of northern Taiwan, your commute is likely defined by this, a suffocating sea of metal and exhaust. For decades, the region's growing population has struggled against infrastructure that simply cannot keep up with the volume of traffic. To ease the pressure, a new crossing was needed at the mouth of the Tamsui River. This wide estuary creates a physical divide between the east and west banks, forcing thousands of drivers into major bottlenecks every day. But the estuary is more than a transit gap. It is a protected natural landmark. The area is world-renowned for its sunset views over the Taiwan Strait, a site that the local community was determined to protect. When the government proposed a new bridge, the public response was a non-negotiable demand: fix the traffic, but do not clutter the horizon with massive concrete support towers. This constraint meant a standard multi-mast suspension bridge was off the table. Engineers couldn't rely on the symmetry typical of most large-scale crossings, forcing them to pursue a specialized asymmetric configuration. A typical dual-mast bridge would have required dropping thick concrete pillars right into the middle of the river. That design would have physically sliced up the view, violating the public's primary rule for the project. Instead, the winning proposal featured a single-mast, asymmetric cable-stayed design. This pushes the main support tower 200 meters into the air, but keeps it far off to one side, hugging the shoreline. The resulting profile is striking. Nearly a kilometer of road made from tens of thousands of tons of steel and concrete extends across the water, held aloft by cables anchored to that single point on the shore. Without a central pillar to balance the load, what keeps this lopsided structure from yielding to the massive downward force of the longer span and collapsing into the water? In 2015, Zaha Hadid Architects took on the challenge. Their team proposed a design that relied on complex tension mechanics to solve the problem of the uneven span. A traditional cable-stayed bridge distributes weight evenly around a central mast, like a balanced seesaw. Danjiang's off-center mast creates a massive imbalance, threatening to tip over. Engineers packed the shorter shoreside section with heavy concrete, creating opposing tension to stabilize it. Throughout construction, every new segment of steel decking added over the water had to be meticulously calibrated against the weight of that shoreside anchor to maintain the balance. The structure achieves stability through this precision load balancing. It uses the concentrated weight of the shoreside span as an anchor, creating the tension necessary to keep the long section suspended over the river. Maintaining this balance is one thing in a vacuum, but Taiwan is located on the Pacific Ring of Fire, meaning this bridge has to survive some of the most violent dynamic forces on Earth. The first threat is seismic. Taiwan frequently experiences powerful earthquakes that can easily fracture foundations and level conventional buildings. Then there are the typhoons. Category 5 storms regularly batter the coast with extreme winds, putting massive lateral pressure on a tower this high. This cross-section shows the primary defense. The mast rests on columns drilled deep beneath the riverbed, anchored into solid bedrock. When shockwaves or extreme winds hit, kinetic energy channels down these columns, dissipating safely into the earth to maintain stability. This makes the single mast more than just a pivot point for the cables. It is a reinforced anchor designed to withstand the region's intense environmental pressures. In October 2025, the project reached a major milestone as crews successfully installed the final segment of the steel decking. This final connection completed the structural loop, formally proving that the asymmetric tension system could successfully link the east and west banks. When the bridge opens in May 2026, it will stand as the longest single-mast asymmetric cable-stayed bridge in the world. Most importantly, the original rule remains unbroken. The center of the estuary is clear, and the sunset over the Taiwan Strait is exactly as it was before construction began. By respecting the environmental constraints of the site, the project team was pushed to innovate. The result is a structure that solves a regional transit crisis while remaining in harmony.
Like, share, and comment. Subscribe.